Hiya students, hope you are staying safe, keeping well. Right, so now we come to the last topic of our course, and that is environmental concerns and technology. And I really hope that you find the final topic to be interesting and not a dreary and boring topic, because this is very closely related to all of us. It's about waste, sampah kan. And from this topic, we'll be able to see that the waste that we're talking about is not just about the solid waste that we commonly see in the domestic waste. It could also be waste coming out from factories, plants, processing plants, which we do not commonly encounter, but they could be a threat and risk to the environment. Okay. And of course, the topic will be concerning the potential contamination risk and how we mitigate that in terms of soil. Right. Okay, so for the solid waste, this is how we would start the topic with, as on landfills, and it will be very common. This is a common sight. You'll be familiar with this probably. Landfill is the technical name, the common name that we say is a dump site. All right, you can see this is how they look like: loads and loads and loads of rubbish. And sometimes you could see some creatures flying around, not necessarily vultures. In Malaysia, you probably don't see many of those. Sometimes they're just, if you're near the sea, near the coastal area, you probably find seagulls, and that is sad, isn't it, having seagulls flying around in the dump site. So this is how they look like. However, if it is a more controlled situation, or when it is done, when the landfill is completed, they will backfill it. Now, this is how it could look like if it's being managed properly. This is one that is in Belgium, as you can see. What we have here is that they have a biogas collection system, because they know when the waste is biodegrading, they will exude release these biogases, like methane especially, and methane can be used as fuel, if you like, to generate electricity and to run the generators and all. So in this case, the biogases are being collected, pumped through the turbines and all to generate green power. And when they are running these the pumps and engines, heat is being generated. And being in Belgium is a cold country, so the heat is being collected and being used to heat up the offices in the plant itself. So that will save up on heating bills as well. Okay, and apart from that, the green technology that is being adopted in this particular landfill in Belgium is a solar panel installation. So again, they produce more green energy there because of the large exposed surfaces you have. So for this, you can see a better example here. That is in Atlanta, in the States. So you see this green thing here, the green covering. Yeah, those are the geomembranes, a special liner, thermoplastic polyurethane. So they resist the UV light, heat, and all. Good covering so that runoff precipitation that's from the rainwater would not penetrate the landfill and cause leachate to come out. We'll see later on more about this leachate. And you can see these solar panels here. They're being used to contribute to the grid, national grid line, generate electricity. And again, it has methane gas collection that is beneath the solar panels, and they are used to run the generators, run the engines for power production. Okay, so you can see a dump site that we originally saw it as dirty, filthy, messy, and now they could be turned into innovative landfills such as these. Okay, right. So now we move into how these dump sites or landfills could cause soil contamination. Okay, and see when there's a symbol of the sun and the cloud, you should pay more attention to it. Okay, right. So what we have here is that the soil, the ground underneath, is being separated into the unsaturated and the saturated zone. You will recall, unsaturated means that not all the soil voids are filled with water. So understandably, this is the groundwater table. So anything beneath it will be fully saturated. So meaning that all the voids will be fully filled with water. Okay, and this is your waste dump. Alright, presumably there's no lining at the base of it. So when rain comes, precipitation, water goes in, brings down all the juices, right? Of course, of the rubbish that we dump, whether it's organic contaminants or inorganic contaminants, all sorts are in there. So you think about it, it could be food waste from our kitchen, it could be chemical waste from any of the factories, simple things, even from our household products, batteries. Where do we throw our batteries? Used batteries, we throw it in our bin goes to the dumpster goes to landfill. Okay, so all these juices will go through to the base of the dump site or the landfill, brought out by the rainwater from precipitation, and they form leachate. Can you see here? Leachate, that's a liquid, the juice, right? The toxic juice. And when the infiltration capacity of an unsaturated zone, the soil around here, couldn't take it anymore, you exceed the capacity that can hold the leachate, it will start to flow down. Where? In joining your groundwater. So when it joins the groundwater, that is not very fun anymore, because you start to flow following the gradient of your groundwater movement. So right beneath the dam side, we have the core zone. It will move further away following the groundwater flow gradient. It's active zone. Eventually, it will reach a neutralized zone where the concentration of the contaminants become less hazardous or below the risk level. And now let's take a bigger view of what is going on. From the dam side, you have gases coming out as well. We call them pore gases because the gases coming out will be filling up the voids in your unsaturated zone. Remember, the voids are not all filled with water, so there's still space for the gas to come through. And these gases could be traveling on their own, because gas is a kind of liquid, it's fluid, alright? It can flow through nicely, or it can be dissolving into the water, and that again happily flow with the groundwater. Okay, as you can see here, surely around the ground surface we have agricultural land, vegetation and all, so the root will be taking up the water, and if it's contaminated, you can imagine what will be taken in by these plants. Say we have corn, durian, rambutans and things like that, so food crops if you like. So if you're taking in the contaminants from the dump site through the leachate, you can imagine the health risk that it can posing to us without us knowing it. That's silent killer. And another risk is from the groundwater that we pump up, mineral water, right? Bottled mineral water and so on. So it's supposed to be filled with mineral and clean and good and pure, but once it's contaminated, we never know what we are taking, what we are drinking. I think it's safe. Alright? And this movement of the contaminants together with the groundwater, we call them the contaminant plume. That's the word plume. Remember, this is a two-dimensional diagram, so what you see is like, oh, it's just elliptical shaping. But remember, they are three-dimensional, so it will be like a balloon thingy growing bigger and bigger. Alright? Okay, and what are the sources of subsurface contaminants, contamination? As you can see, we could have liquid pond or impoundment, meaning that we excavate into the ground and pump in our waste that is coming, that's in liquid form. Or we could be having buried waste, and these buried waste is like the most exciting one, probably be the radioactive waste that irresponsible people will be dumping in the middle of the night, pop it into the ground and bury it outside, out of mind. And many years later, someone built a house around this area and find that, oh, they have radioactive reactions and becoming like X-Men and things like that. Then they found, oh, we have some radioactive waste being buried in the backyard, things like that. And this is true. There's I have seen a true case happening in Japan. It came out in the national news, right? And the third one here, the third source, as you can see, is what we have discussed earlier, the solid waste dump. So if it's not properly lined, not properly taken care of, later on we'll see how we can take care of it properly so that we can minimize the risk of contamination, right? And you get underground storage tanks, especially from the refinery or chemical processing plants, right? And all these will be, if they ever leaked out, it will be joining the groundwater flow, as you can see, and eventually where we go? Downhill, right? Downhill following the gradient, and it will somehow, at one point or another, it will reach our source, surface water source at the river. And we know what we use our rivers for: irrigate our agricultural land, use it, pump it out, filter out, process it in our water treatment plant and start drinking and things like that. So you can see eventually it reaches us human beings at the top of the food chain, and it can be very, very risky, and because we don't even know that we have such contaminants in the water. Okay. And for the leachate flow rate, how fast it could actually travel depends on the 4 factors here: the hydraulic gradient, the permeability of the soil, your initial water content of the soil, and the infiltration capacity. The details of these you can find in your in the module. They are pretty straightforward, okay, so you can read through that yourself. And that is through the unsaturated zone. Once it has come down to the saturated zone, meaning that it will join the groundwater after it has exceeded the infiltration capacity of the unsaturated zone, what will it do? It will start to propagate, right? Remember the contaminant plume is like a mushroom ballooning away. So the process of it being transported away from the source point is by, number one, it could be advective. When we say advective, means it's flowing under a hydraulic gradient. Okay, and it could be diffusive. If it's diffusive, the term diffusive has got to do with concentration. Right? We learned in chemia, right? Concentration gradient, meaning that from place that is high concentration. Pekat ke cair lah senang cakapnya. Alright? It could be dispersive. Simply dispersive is a disrupted movement. It's flowing under variable velocity, so it could be going all over the place now at different rates, and changing velocity of the flow rate could be due to many factors. Among them, it could be because of the changes in your soil type. It could be changes in the permeability of your soil. All right, and the fourth situation is that you have a combination of any of these from the above processes. Okay, and but do bear in mind that not all contaminants transporting themselves or moving in liquid form. It could be in gas form as well. And we recall we talked about the pore gases coming out from the dump site. Now, in fact, gas is even scarier because gas is more compressible, it's more fluid. It could be, number one, it will be going through the soil pores on its own, or it could be dissolving into the water and going through, flowing together with the water. So the gases and the gases could spread faster, understandably. If what can we do to avoid this contamination from coming through to us? There's such a thing called the geochemical trap or geochemical filter, right? What is their job? Their main function, they function to immobilize or to retard some of the contaminants. Read this carefully. Some, not all. There's always a risk that some will actually escape, some are being trapped. So the ones that are being that escape the trap, if they are of low level or they are of not that high risk level, that is alright. But what if they are of a rare species of contaminant or something that has hit the red level and we don't know? So you can see here that that's why it's important to have this geochemical trap. And it concerns the ability of the soil to interact and retard the contaminants. And the term that we use is called the geochemical attenuation capacity of the soil, meaning that the soil has a capacity to slow down or to reduce, not totally eliminate, to reduce, to minimize, alright, the effect of these contaminants. And what kind of soil do you think you'll be using for this purpose? Obviously, it's clay, not sand, right? Why? Because sand is more porous than clay, and sand will be more encouraging than clay for the contaminants to flow through because of the larger voids connecting the soil mass. Okay. And what are the effects of having this subsurface contamination? One of the scariest things that can happen is that our groundwater aquifer down there is being contaminated. And we do know that that is bad because we pump out the water and we start drinking it. It's bad. And the second situation is that we could have these contaminants coming in and contaminating our soil. Not necessarily about something that is toxic. It could be as simple as salt. Seawater coming in, and if we call them the seawater invasion, and increased salinity of the soil will change the properties of the soil, and it could become we could have a situation where the soil becomes no longer usable for agriculture purposes. For example, if you are planting for example paddy, right? Paddy fields, if you have too much of salt coming into the paddy fields, then the paddy will not grow well. They may not all die out, but if they're not growing well and giving you the yield that you want, then it's really bad for the farmers. Okay? And in order to detect that, we have ways of doing that. We can do surveys, and the best way is still to drill at points, at selected points, and to know how concentrated, how bad the contamination is. We could use geophysical methods that are using sounding methods, electromagnetic, and all to get the measurement, again, idea of how bad the contamination, how extensive or how severe it is. Alright? And last but not least, we could monitor these possible contamination risks. And as you can see here, this is the dump site. Plan view, this is side view. You have gas monitoring wells and you have groundwater monitoring wells. Notice that we have them on the upstream and also the downstream to capture the possible contaminants, and see that we have these groundwater monitoring wells on the left and right of the downstream part of the dump site as well. Why? Remember the plume? The plume will be expanding and going out in a balloon shape. Hence, we need them more on the downstream side. Okay, so we pause here for a bit. We'll move on to the next subtopic.